In this barometer question, you have a test tube with air inside here, so take note it's not vacuum, and you have a column of mercury of height h from this level, and on top of the mercury you have a layer of water which is 27.2 cm height. Now the first thing we need to do is to write an equation, and the reference point I take will be here and here because it's the same height, same liquid, so the pressure at these 2 points here will be the same. Let's start with point number 1. So at point number 1, the pressure is due to the pressure of the air plus pressure of the mercury due to a height h, and this pressure is actually equals to the pressure at point number 2, and this pressure is due to the pressure of the water plus pressure of the atmospheric pressure, which is acting outside here, so do not forget about that. Next, let's sub in the value in terms of mercury. Given that the pressure of the air is 4 cm and this column of mercury is capital H here, and for the atmospheric pressure that's acting outside is given that the pressure is 76 cm of mercury. For the 27.2 cm of water, you cannot just put in the value here because everything has to be consistent in terms of mercury. So what we need to do is to convert 27.2 cm of water, convert it to mercury. It is given that the density of the mercury relative to water is 13.6. So basically it means that mercury is 13.6 times heavier than water. So this water creates a pressure, but instead of using water, you want to use mercury. So what's the height of mercury that's needed to create the same pressure? So you know that since mercury is heavier, 13.6 times heavier, so it will only need 27.2 divided by 13.6. So you basically need 2 cm of mercury in order to achieve the same pressure created by 27.2 cm of water. So we put in the 2 over here, so there you have it. You can solve for H, which is 74 cm. So the answer will be B.